You need to be able to find the equation of both tangent lines and normal lines to the curve given by a trigonometric function. So just to remind you of what that means, this is the curve that we're actually going to be working with, cos of 3x, and this is the point at which we want that tangent line to occur, when x is pi over 9. The tangent line looks like that, okay, passing through that point, and we should recall that the gradient of the tangent is equal to the derivative at that point. If we want to find the equation of a normal, then that meets at right angles, passing through the same point. And so because it meets at right angles, the gradient of a normal will be the negative reciprocal of the gradient of the tangent. Okay, so you've done tangents and normals before. Let's look at how we do them, or review that process, I guess, in the context of a trig function. So, the first thing we're going to look at is the equation of that tangent line. So, first thing that you should do is this here. As soon as you see it ask for a tangent or a normal, you should be finding the derivative. So, the derivative of this function, it's a chain rule. Derivative of cos is negative sine of 3x multiplied by the derivative of the inner function. So it's negative 3 sine 3x. Okay, if we want the gradient at that point, we're going to sub in pi over 9. So the value of the derivative we're looking at negative 3 sine pi on 3. And here's where you should be going to an exact value triangle. That one there. And so sine of pi on 3 is opposite over hypotenuse root 3 over 2. So that's negative 3 root 3 over 2. That's our gradient of that tangent line. So if we think about what we're doing here, we're ultimately going to be substituting into this. Okay, or using y equals mx plus c, substituting, solving for c, but this does the same thing. So we have a gradient now, and we have our x value, but we do not have a y coordinate. And to get that, we substitute pi over 9 into the original function, which was cos of 3x. Now, going back to our exact value triangle, this ends up being cos of pi. Cos of pi over 3. Cos of pi over 3 adjacent over hypotenuse is 1/2. Okay, and we would substitute that in there. Done. That's a tangent line. If, for whatever reason, you wanted it in the form y equals mx plus c, all we would have to do is add a half to both sides, and then expand the brackets. Okay, and that's the equation of the tangent line. If we want to do the normal now, then the process is exactly the same. So for the normal line, we need to first find the gradient of the tangent, which we've done. from this point, we now have to calculate the gradient of the normal, and that's going to be the negative reciprocal, 2 over 3 root 2. 3, sorry. And then it's the exact same process. This is the same. The x value is the same. Right, so we're going to simply substitute into this using our different gradient now. Y is the same. Remember at the start I showed you it passed through the exact same point, so the x coordinate, the y coordinate are the same. And x is the same. And again, if we wanted y equals mx plus c, we would add a half to both sides and expand out the brackets. Okay, and now you have the equation of the tangent and the normal in the form y equals mx plus c. There's the gradient. There's the y-intercept. There's the gradient. There's the y-intercept.